Welcome, Hononegah Geometry, Section 2.1, Day 2 today. So we're going to expand a little bit on some of the information that we learned yesterday. And so the very first question is literally yesterday's: write a conditional, converse, inverse, contrapositive statement. So 2.1, Day 1. Then determine whether the ones that are true and which one are false. All right, so I need to write this as an if-then. And I know I don't have any room necessarily on this slide, so I'm just going to read through it. So the conditional would be: if you have obtuse angles, then the measure is more than 90 degrees. The converse: if you have angles more than 90 degrees, then they are obtuse angles. The inverse: if the angle is not an obtuse angle, then it is not more than 90 degrees. And the contrapositive would be: if the angle is not more than 90 degrees, then the angle is not an obtuse angle. All of those would be true. Now, the statement below is false. If a number is divisible by 5, then it also is divisible by 10. Now, there are some examples that are true, but there are some examples that are false. So when you are asked to come up with a false example, make sure that you actually do come up with a false example. For instance, 15 is divisible by 5, but 15 is not divisible by 10. And when I say that, divisible evenly. So obviously 15 divided by 10 is 1.5, but not evenly. All right, so the talk of today is going to be about our inverse, our converse, and our conditional, and then we're going to talk about what's known as bioconditional. So here we go. You can write any definition that you come up with. You can write it in an if-then form, or as its converse. Both conditional statements and the converse are true definitions. For example, consider the definition of a perpendicular line. If two lines intersect to form a right angle, then they are perpendicular lines. The converse of that would be: if two lines are perpendicular lines, then they intersect at right angles. And for our purposes now, we're going to start teaching you some symbols. This would be the symbol for perpendicular. It's an upside down T. So it looks like basically two lines or two segments that make a right angle. So the next page, decide whether each statement about the diagram is true and explain your answer. Give me a reason for something to be true, or give me a reason for something to be false. So I'm looking at this picture and I see that there's a right angle. I'm going to circle that. That's important for us to see those. That means that these are right angles, and these two then would be perpendicular. So automatically, the first one, AC, is perpendicular to BD. That's true, because right angles, or perpendicular lines, intersect at 90-degree angles. So that right there told me that everything there is perpendicular. The next one, angle AEB, so looking over at my picture, AEB, and angle CEB are a linear pair. That again is true. Two adjacent and supplementary angles form a linear pair. Also, if you just said something about two angles that make up a straight line. Okay? Also, EA and EB. They are rays that have the same endpoint, but these are not opposite rays. Opposite rays need to create a straight line, and these do not. Try these on your own a little bit. So go ahead and hit the pause button as you're at home, and then I'll put the answers up. All right, welcome back. JMF and FMG are supplementary. That is true. Again, linear pair. Two angles that are adjacent that make up a straight line. Point M is the midpoint. That is false, or you don't have not enough, can't spell there, not enough information. I don't know for sure. I can't assume that M is the midpoint without any further explanation. JMF and HMG are vertical angles. That is true. Sorry for the interruption there, but vertical angles are angles that are opposites of each other. Or I like to just put the definition of a vertical angle. And the last one, FH is perpendicular to GH. That is false. You can't assume that. Not enough information. Here's the big topic of the entire day. It's called bioconditional statements. Bioconditional statements is if the conditional statement is true and the converse are true. A bioconditional statement uses the phrase if and only if. And the symbol for a bioconditional statement is P, then Q, then Q, then P. So both are true. So rewriting statements backwards and forwards as a bioconditional, and you're going to use the words if and only if. Array is an angle bisector. If and only if, it divides an angle into two congruent angles. That's an example of a bioconditional. An angle is obtuse if and only if it measures more than 90 degrees. It is true one direction and true the other. And notice you have the if and only if. And so the last one, two angles form a linear pair if and only if they are adjacent and supplementary. Rewrite the definition of perpendicular lines as an if and only if. So bioconditional here. So if two lines intersect to form a right angle, then they are perpendicular lines. So writing that as a bioconditional, two lines form a right angle if and only if. This is the key when writing a bioconditional. If and only if they are perpendicular lines. If possible, rewrite the conditional statement. Now, it's got to be true both directions. So if you are at least 16 years old, then you can drive. Look at it the other way. If you can drive, then you are at least 16 years old. That is true. So I'm now going to write this as a bioconditional statement. You are 16 years old if and only if you can drive. If it is April, then there's 30 days in the month. If there's 30 days in the month, then it's April. That is false. There are more months in the year that are 30 days, so therefore you cannot write a bioconditional statement on that. Go ahead and hit the pause button and try to write these as bioconditional. All right, here we go. If an angle is a right angle, then it measures 90 degrees. An angle is a right angle if and only if it measures 90 degrees. Determine it below if the statement below and its converse are true. If you can, rewrite it as a bioconditional. If you run for president, then you are at least 35 years old. If you are 35 years old, you can run for president. That is true. So, as a bioconditional, you can run for president if and only if you are at least 35 years old. Homework assignment is the 2.1. Make sure you check with your teacher, and if you have any questions, and good luck.